Hello and welcome to your Science News Update. We've got some fascinating stories for you today.
All right, first up, let's take a trip to the moon. Turns out its history is being completely rewritten. We think of it as this quiet, peaceful neighbor, but new evidence suggests it had an incredibly violent past.
So get this, a massive, ancient impact did way more than just leave a crater. We're talking about something so huge, it literally reshaped the moon's entire inside, kind of churning it up. This wasn't just a scratch on the surface. It was a total planetary-scale makeover.
So you might be asking, how on Earth do we know that? Well, the proof is in the rocks, specifically some really rare samples brought back by China's Chang'e 6 mission. They managed to grab these from the far side of the moon, a place we rarely get to study, and they are the first real physical proof we have of this giant internal shakeup.
Okay, so from the massive scale of the moon, we're now diving into the complete opposite, the tiny, weird world of quantum physics. And it's a big deal, because a puzzle that's been stumping scientists for decades has finally been solved. This all has to do with something called quantum matter. Now, what is that? It's basically a state where a whole bunch of particles just stop acting like individuals. Instead, they start showing these really strange group behaviors that just don't happen in the world we see every day. It's pretty wild stuff.
For years, physicists were kind of split on this. There were two big ideas. One was that if you put heavy stuff, impurities, into a quantum system, it would just freeze everything solid. The other idea was that maybe, just maybe, some movement was still possible. Well, researchers at Heidelberg University have finally settled it. It turns out those impurities do move, just a tiny bit. And that little bit of movement is enough to let all these new exotic particles pop into existence.
So what this really means is that we now have one unified theory that brings these two seemingly opposite ideas together. It's like having a complete instruction manual for how these super complex quantum systems work, which is huge. This could open the door to all kinds of new materials and technologies down the line.
All right, let's shift gears from physics to the deep past. There's some new research coming out about Europe's earliest wars, and honestly, the findings are pretty chilling.
The really startling takeaway here is that warfare back then wasn't just a random, chaotic fight for survival. No, the evidence is pointing towards something much more organized, even ritualistic. It suggests a level of social structure, and frankly, a brutal kind of tradition that we just didn't know existed this far back.
When archaeologists looked at mass graves from the Neolithic era in northeastern France, they saw a clear pattern. The way people were injured, the way they were buried, it all pointed away from a messy skirmish and towards something structured, something organized. This wasn't random at all. It was deliberate. We've got a couple more great stories for you. But real quick, if you're enjoying these science updates, it would be a huge help if you could take a second to like and subscribe. It really helps us keep bringing this news to you. Okay, for our next story, we're heading all the way down to Patagonia. There's a really dramatic ecological clash happening right now between a returning native predator and a huge colony of penguins. And the numbers here are just staggering. Scientists have counted more than 7,000 adult penguins killed by pumas in only 4 years. That is a massive new pressure on a population that really wasn't used to dealing with predators coming from the land. But here's where it gets complicated. The pumas aren't an invasive species or anything. They're actually native predators, just returning to a place they used to live. The real issue is that the penguins on the mainland have had a long time without any major land predators. So they haven't evolved the defenses for it. This creates a brand new and really deadly dynamic. And for our last story today, we're talking about our global climate. And specifically, the absolutely critical role played by some of the tiniest life on our planet, a role that it seems we've been seriously underestimating. The problem is, this might be a major blind spot in our climate models. Those incredibly complex computer programs we use to predict what's going to happen to our planet? Well, scientists are warning that they might be missing a key player: tiny little marine plankton. So how do they help? It's a really simple but powerful process. These little guys build shells for themselves out of calcium carbonate. To do that, they have to pull carbon out of the atmosphere and into the ocean. Then, when the plankton die, their shells sink to the bottom of the ocean, taking that carbon with them and locking it away for hundreds of years. And researchers are really stressing this point. These organisms are not just some minor footnote. They are a huge engine in the planet's carbon cycle. They're like these tiny, tireless janitors, quietly helping to regulate the entire Earth's climate.
So let's do a quick recap. We've seen how a violent impact totally reshaped the moon's interior, how a decades-old quantum physics puzzle was finally solved, and we've looked at some chilling evidence of ritualized warfare in ancient Europe. We also touched on a modern ecological clash in Patagonia and the massive, overlooked role of plankton in our climate.
And that's it for today's Science News. We'll be back in 24 hours with another update.